Hi, my name is Ms. Leminski, and I am going to help you guys learn Topic 2 through some videos. You can see on this slide that in Topic 2, we will be talking about quadratic functions and equations. So we'll just be extending what you learned already about functions in Chapter 1. Starting with Section 2.1, we're focusing on the vertex form of a quadratic function, and our key idea is that I can identify key features of quadratic functions. The first day of this lesson, we are going to focus on describing transformations of a quadratic function in vertex form and determine the key features of a quadratic function given vertex form, including the vertex, axis of symmetry, max or min, domain, and range. Before we begin, I wanted to look at this little activity just to start getting our minds wrapped around how a quadratic works. The table represents a of x, the area of a square, as a function of side lengths, x units, where x is a positive real number. So you can see in the first column, when x is the side length, we have the area as x by x, so ax is going to be x squared. And that is a quadratic. Anytime the x is squared, we're talking about a quadratic function. We'll talk more about that today. Okay, so if a side length is 1 by 1 has an area of 1. 2 by 2, area of 4, because we're multiplying length times width or doing x squared. 3 by 3 or 3 squared, 4 by 4 or 4 squared. Okay, you want to pause the video and try to answer questions A, B, and C. These are good priming activities to get your minds thinking about these quadratic functions. Okay, so it said consider the function where the areas in the table are doubled. Write the equation for a function that represents this. Okay, so area is the output based on what you learned last chapter. And so to double the output, so I'm going to write a function f of x, I need to multiply the y values by 2, so it would be outside of the quadratic. Since it's just x squared, it could look like this. It says look for relationships. Graph the ordered pairs for both a of x and your new function. How would you describe the differences? Again, if we think about what we learned last chapter, that 2 is going to affect it vertically, which means it's going to be a vertical stretch. So this is the first one. Okay, so this is a of x. But then if I graph f of x, if I plug in 0, I still get 0. I have a point at 0. But if I plug in 1 squared is 1 times 2 is 2. And then it's symmetric, so we can always find 1 and then just reflect it across the line of symmetry, which we'll learn about. And then if I plug in 2 for x, I get 2 squared, which is 4, times 2, which is 8. So 6, 7, 8, that's way up here. And now we can visually see what we learned last chapter is that 2 out front vertically stretches it. All right, letter C, find the equation for a function whose x values are the same as a of x, but whose y values are 2 units greater. Greater than means we want to add. So in that case, you could have just done g of x equals x squared. We don't do anything to the x's, but we add 2. Okay, so again, you may have understood that, you may not have, but the good news is it's okay either way because we're going to learn about those things again today. Before we get into that, though, we need to really understand the quadratic function. Okay, so we're focusing on that specifically this chapter. A quadratic function can be written in the form f of x equals ax squared plus bx plus c. And just so you know, this is going to be called standard form. Well, real quick, a can't be 0. So we're focusing on the fact that it's squared, and this is called standard form. Now, when I put these little pencils up here, these would be good things to get in your notes. So the previous one, if you were doing some work, you could write it down, but you didn't necessarily have to write it out. But this would be some vocab you want. Transformations of the parent function are defined by f of x equals x squared. So anytime we say compared to the parent function, we're talking about x squared. The graph of a quadratic is called a parabola. And now vertex form of a quadratic function, which is what we're focusing on this chapter, is f of x equals a parentheses, so times x minus h squared plus k. where the HK gives us the vertex. That's the ordered pair of the vertex. Now, last chapter we did talk about already how these transformations or translations, the sliding the graph left, right, up and down, work. And that's going to carry over to this, and we'll look at that on the next slide. If we were to graph just x squared, you can see that picture right here, where the vertex is at 0, 0. So that's the key feature of x squared. Axis of symmetry is the line that cuts the graph in half. So if I drew it in here, it's a vertical line through x equals 0. Vertical lines are x equals because all of the x values on that line are 0. The minimum value right here is at 0. That's a y value because it's a height, a max or a min. Domain, remember that's talking about what can I plug in for x. If I'm going to square a number, I can plug in anything. So in interval notation, it's negative infinity to infinity. And finally, range, those are the y values. Now, if I square any number, I can never get a negative because anything times itself is going to end up positive. But I am allowed to square 0. So 0 squared is 0. So the lowest value I would ever get is 0. And the highest value would go up to infinity. So my range is from 0 to infinity. Remember, when we include a value, we use that square bracket. If we don't include, or anytime it's next to an infinity, we put the parenthesis, and that's because we can't touch infinity. Okay, so that's the basic background of a quadratic function. This is a quick review of what happens when we start putting in different h's and k's and start transforming a quadratic function. The key is that transformations follow all the same basic rules that all functions follow, like you learned last chapter. Again, you can see there's no pencil up here, so don't worry about writing this down. Here's how I like to think about it, though. Anytime something is grouped with the x, it affects the graph horizontally, which means left to right. Okay, so it's going to shift the graph left or right if we're talking about a translation or a shift. And if we're talking about a stretch or compression, it's going to shrink it horizontally. Anything outside of the grouping with the x affects the graph vertically, the same as what you would think. Oh, I forgot to talk about that last one. So vertically is always the same as, so it's going to shift it up, down, or compress it or stretch it the way you would think. Going back up to the horizontally, though, it's going to be the opposite of what you would think. Okay, and we'll talk about that a little bit on the next slide. This is the one that you want to write down. Okay, again, we have f of x equals a parenthesis x minus h squared plus k. The value of h, let's start with the h. Okay, we said the h and k give us the vertex. The value of h determines the horizontal translation. Since it's inside the parentheses with the x, that means it's impacting the x value, which is why it's moving it left or right. But now remember, in chapter 1, the x minus h, it's the opposite of what you would think. So if this was a 2 here, if I see x minus 2, I might think left 2. But remember, it's because I am subtracting a positive 2. So x minus 2 actually moves the graph right 2. Okay, so that's the horizontal translation. Now k, which is being added outside of the grouping, okay, that's going to affect the graph vertically. So if I add k, it's going to move it up and down, so translating it up and down, and that's the same as what you would think. So if that's a plus 4, you would move it up 4. Now, this a is what we kind of looked at in our warm-up today. A is a number. It is outside the grouping symbols with the x, so it actually is going to impact the y values, and it actually is going to determine the direction as well. So if a is bigger than 1, it's going to stretch it vertically. If it's between 0 and 1, it's going to shrink it vertically. But then if it's negative, it's actually going to reflect it over the x-axis, which means it's actually going to flip it upside down. Okay? So that's the major background information we need. And now I'm going to do a separate video with the examples of how you're going to do problems. So now I need you to go to the second video to see those examples worked out.